Alright, welcome. So in this video, I'm going through some examples of how to do things with equations of lines in 3 dimensions. So we're going to find an equation of a line, and then we're going to look at where a line and a plane intersect. So this definitely doesn't cover like everything you could possibly do with equations of lines, and there might even be some problems that you're asked to solve that involve some other techniques or like thinking through things, but this is enough to get you started, and then I'm hoping that with supplemental videos or just like playing around with the ideas, you'll be able to get the other problems that are asked of you. But please don't worry, they won't be too hard. I just want to say that like I'm aware that I'm not doing every possible type of example that might come up with this topic. Okay, so for our example, first we just need to practice with our formulas for the vector and parametric equations of a line. So I just want us to find these equations for some points. So let's find the vector and parametric equations. And these are for a line. And I'll give you a point and a direction. So we have the point, let's say it's 4, -2, 1. So that's my point. And we'll say it's in the direction, and I'll give you a vector here. So it's in the direction of 1, 1, 2. Okay. So we have a point and we have a direction. So you can remember that the formula for how this looks at the end, we're going to find the vector equations first. So this is going to have a vector pointing in the right direction plus t times the vector, so this has a vector pointing at the point, so that's our r naught, and then we have a vector times t pointing in the right direction. So sorry about that. So for our r naught, we're going to use the point. So this r naught is going to deal with the point. We're going to take a vector that points at the point. So we're going to take those components and make them the components of the vector. 4, -2, 1. Okay, sorry, got a little cut up there. So we just take that point we're looking for, that becomes the vector that we want, that points to the point. So you might label it to help you out. That's a vector pointing to the point. Then we're going to add it to the vector that's sort of pointing in the right direction, the direction that we were given. So I'm going to add it to now t times that direction vector. That's my v vector. 1, 1, 2. Oops. So here, that v vector is the vector pointing in the correct direction. All right, so we've actually basically done the vector equation now. I just kind of like to put them all together into one vector, although you really could just leave it like this. But if we wanted to go one step further, what we would do is just combine everything into one vector. So I have 4 plus t, that's 1 times t. And then I have my second component, I have -2 plus t times 1, so plus t. And then I have 1 plus t times 2, so 2t. So I'm just taking my components, my x components, and then my y components and my z components with the t multiplied in. All right, and this would be my vector equation for the line. All right. Just trying to wrap this up here. Let me write this out, and I'm just going to label it really quickly just so we have it. This is the vector equation. Okay, so we were also asked to find the parametric equations. Since we've already combined these into one vector, we are just going to take out the individual components and make them the equation. So x of t is the x component, 4 plus t. Y of t is the y component, that's -2 plus t. and z of t is the z component, which is 1 plus 2t. And together, these are our parametric equations for the line. So I'll label those parametric equations. Okay, so those are the equations for this line. We were given a point and a direction, and this is what we got. So I just want to do one more example. For this example, I want to know where a line through a point in a certain direction intersects a specific plane. So we're just trying to amp things up a bit, give us something else to do. So I'm going to ask, where does the line, and let's say it goes through a point. Let's say it's through 3, -2, -2, and it's in the direction of this other vector. So let's say it's in the direction of 9, -1, 6. Let's figure out where the line that goes through this point in this direction intersects the xy plane. All right, so first we need to have the line so that we can determine where it intersects. So I see this as kind of two separate tasks. The first task is to get the equation of the line. So let's just do that really quick. Let's get the vector version of it. So my equation of the line, that's the r of t. We're going to take the vector pointing at that point, 3, -2, -2, and then we add it to the vector that points in the correct direction. So we add it to the vector 9, -1, 6. And don't forget your t out front. We need that t being multiplied by that vector to help us go through the vector, I guess, to trace the line. So this is my line. I'm just going to multiply everything together just to get my vector. So in the first component, I have 3 plus 9t. Then I have -2 minus t. And then I have -2 plus 6t. So hopefully you can follow that through. I'm just taking like the x components and then adding them, and then the y components and adding them, and the z components and adding them. So what we found here is the line. This is the line we're looking at. And our next task is to figure out where this line intersects the plane. So specifically, we're looking at the xy plane. And what characterizes points on the xy plane is that they don't have a z value. The z value is 0. So the xy plane has a z value of 0. So this means that in my equation of the line, this z value needs to equal 0, because we want to know where that line intersects the xy plane, and that's going to happen when the z value is 0. So if we look at the parameterized equations, x of t equals 3 plus 9t, y of t equals -2 minus t, and z of t equals -2 plus 6t, we're going to take this z of t equation and set it equal to 0. So that's the z value of 0 that we had written above. So z value of 0 gets put in there for equals 0. Okay, so this is going to help us find like at what time that line is intersecting the plane. So we have lots of t values. We are going like, you could say probably for like a span of t values for time values. We want to know when it intersects the plane, so we're going to find the t value that makes it true. So I'm going to solve for t here. Moving the 2 over, I have 6t equals 2. And then dividing it, I have t is equal to 2 over 6, which is 1 over 3. So this means that the line intersects the plane when t equals 3. So I'm just going to say at t equals, 1/3, not 3. Okay, so we found out that if I use the value of t equals 1/3, then I get a point that's on the xy plane that's also on the line that we're looking for. So that's where they intersect. So to wrap this up, I know the t value, but I kind of want like the location they're intersecting. It says where does the line like intersect? So we're going to want an x, y, and z point. So we have the z point at 0, but now we need to find the x, y values. So what I do is I substitute in 1/3 into my parametric equations for x and for y. And I already know the z one, it should be 0. So when I put 1/3 in for t into my x equation, I have 3 plus 9 times 1/3. 9 times 1/3 is just 3. So I get 3 plus 3, which is 6. Okay, cool. So that is my x value. Now I do the same for y. Y is -2 minus 1/3. So here I'm going to need some fractions. Let's do 2 is 6/3, so I have -6/3 minus 1/3. That gives me -7/3 as my y value. So from this, I have an x, y, and a z, and so I can conclude that the line intersects the xy plane at the point 6, -7/3, 0. And there we go. That's our solution. Oops. Okay, so there we go. So this video we just did 2 examples. We found 2 equations of lines, and then in the second example we figured out where the line intersects a plane. So that's it for our discussion about lines. In the next video I'm going to introduce some more information about planes actually, and then we'll come up with some equations for writing planes next. So thanks so much for watching, and I will talk to you in the next one.